Okay, another small step up in difficulty. Again, we're asked to factor what I'd call a polynomial expression if it weren't for all these fractional powers in it. But the approach is not all that different. We're looking for common factors in the coefficients, which 2, 5, or 2, nothing there. And are there any common factors as far as the x? Well, every term does contain x, and the lowest power of x which we have is x to the minus 3 over 2, so that has got to come out. As you saw in the previous example, taking out a factor of minus 3 over 2 increases all of these powers by 3 over 2. The idea is we're subtracting a negative 3 over 2, which is the same as adding positive 3 over 2. So all of these powers go up by 3 over 2, and let's see what that gives us. The coefficient of 2 stays put. We get x to the 1 half plus 3 halves is 4 halves. I'll clean that up in a moment. Plus 5, x to the minus 1 plus 3 makes 2 over 2. Get that cleaned up also. And 2 x to the minus 3 over 2 plus 3 over 2 ends up being x to the 0, meaning no x's in that term at all. All right, so if we pretty that up a little bit, we get x to the minus 3 over 2 times 2x squared plus 5x plus 2. Can we factor that quadratic? I think we can this time. They can't all be factored, but in this case we'd need two numbers which add up to 5 and multiply to 4. That's not so bad. We can do that with 1 and 4. So 2x squared plus 4x plus 1x plus 2. This is the method of decomposition. If you prefer to do guess and check, then by all means ignore me for a second. We'll meet up when we've got the quadratic factored. If you're doing decomposition, then these two terms are replacing the 5x. Nothing else has changed. Now I factor this by grouping and factor this by grouping. So we get x to the minus 3 over 2, just sitting outside waiting. From these two terms, I can take out 2x, which leaves me with x plus 2. From the second pair of terms, I have to factor out something, and all I can take out is a 1, so out comes 1, and that leaves me with x plus 2. These factors match. That should always happen if you're doing decomposition. And it means that x plus 2 is actually a common factor. Take it out, and what remains with it gone is 2x plus 1. If you did guess and check factoring, welcome back. I assume you got the same thing that I did here. And you could leave it in this form. This is not such a bad way to write it. Or if you'd rather have positive exponents, you could have x plus 2, 2x plus 1, over x to the 3 over 2. And that's as factored as that thing will get.